Hello everyone and welcome back to my YouTube channel. So we are going through a series of lectures on machine learning. Until now we have discussed in the previous few videos about the clustering techniques, in which we have discussed about partitional clustering and the hierarchical clustering. So now we will do in detail the algorithms of partitional clustering and then hierarchical clustering. In this video, we are going to discuss about the partitional clustering k-means clustering technique. And we will do a complete demonstration of this by using an example of k-means clustering. We will solve a numerical problem for k-means clustering. So let's firstly briefly discuss about partitional clustering. So partition clustering is a clustering which works by partitioning the data. So we say we are given a data set of n items, and we have to form the key number of clusters for these data items. So we say the value of k is given fine initially, and we will be given a few clusters at the very initial stage. So we will organize the objects into these k clusters where k is less than equal to n, where n stands for total number of items. And the clusters are formed to optimize the unobjective partition clustering, in which we say that the objects that are of similar type will be in one cluster, and the objects that are of dissimilar type, they will be in different clusters. So in k-means clustering, the algorithm is very simple and the numerical is also the simple one. So k means number of clusters k should be specified, they should be given, and this is a type of centroid base. So we have k means clustering and k midwise clustering. When we talk of k means clustering, which is based on a centroid, so we take the mean in this case, and the other case when we talk of k midwise, we take the center point, that is the median value in that case. So each point is assigned to the cluster within the closest centroid. So here what we need to do, we will work with the help of Euclidean distance. You can also use Manhattan distance, there is no such issue, you can go with any of the distance matrix. Fine. So when we talk of this algorithm works like we have k points at the initial centroids, form k clusters by assigning all the points to the closest centroid. We recompute the centroid for each of the cluster until the centroid stop changing. So while talking of these algorithms, we can expand the algorithms in a form that we say k means is a unsupervised iterative clustering technique. It partitions given data set into k defined distinct clusters. A cluster is basically a collection of data points that exhibit the certain similarities in the case. And we have partitional rule. So each data point belongs to a cluster with the nearest mean. Data points belonging to one cluster will have a high degree of similarity when they belongs to a same cluster. So let's discuss a few steps of k-means clustering. So the very first step in k-means clustering that is to do is choose number of clusters. Let us call it as k. Then in step 2, we will randomly select what we do. We will randomly select any k data points which are called the centroids for the cluster. These may also be given. If they are not given, then we can select randomly. How we choose? Like suppose we have total 1 2 3 4 5 6 7 8 9 10, let us say items, and we have to pick. So we will pick one cluster centroid from this, another centroid from this, and so on. This is how we take the cluster values. In this case, we choose the centroids that are the initial centroids. So now in such a case, we can pick the centroid like in this case, we can pick the first value and then the second and so on. Right. So when we talk of this k-means clustering, we know that we pick a k clusters at random. We assign them the nearest cluster by using the Euclidean distance, and then we move the each cluster center to the mean of its assigned items, that is assign each data point to some clusters. A data point is assigned to that cluster whose center is nearest to the data point in that case. And then we will keep on repeating these steps, that is repeat steps 2 to 3 until the convergences that says that change in the cluster assignment is less than the threshold. So what we do, we mean to say over here is we recompute the center of newly formed clusters. The center of the cluster is computed by taking the mean of all the data points contained in that. It means suppose initially we were having this cluster 1 and this is cluster 2, and we are having a central point for this P1. In this we are having central point P2. Now suppose for the data item 3, data item 3 goes to this cluster, that is cluster 2. So in that case what we need to do, we need to recompute the centroid. So here we will get the new centroid, that will be the main point, and in the next case for this centroid, when we take the next point, data point 4, we check the Euclidean distance with this P1, and in this case with the newly calculated distance point. So similarly we keep on repeating these steps until we get to the conditions like center of the newly formed cluster doesn't change, data points remain present in the same cluster, or maximum number of iterations are reached. So this is how k-means clustering algorithm works. And so in this case, initial centroids are often chosen randomly. These are the points that we need to discuss and understand. So cluster produced very far from one run to another. The centroid is basically the mean in that case. Closeness is measured by the Euclidean distance, or you can also take the Manhattan distance. We take the cosine similarity or correlation similarity. So k-means will do the coverage from common similarity measure mentioned in such cases. We often stop the condition until the relatively few points change the cluster, or the cluster has stopped changing. The data points have stopped their swapping from one cluster to another. And Euclidean distance formula we already know. So let's have a look at two different k-means clustering. So in this case we are having original points. So how it is working? So in this case, firstly let us say there is centroid point, this is the centroid point and this is the centroid point, and correspondingly these items are having nearest distance to this, in this case this one, and then this one. This is the case how it is working. Now suppose let's see how they work in iterations. So initially we can see over here 3 cluster points. So this is one centroid point, this is another one, and here. Now in this case what will happen, we say that a new data item, any of the data item is going to this point. So what we need to do, we need to calculate the mean of all these values that will actually occur as the centroid point. Now for the next set of items, suppose we want to put in this, it will be checked for the nearest difference from the point, centroid point, and correspondingly assigned the point. So let's see, in this case we can say, so in this iteration 2 we can see when we have recomputed the mean, the cluster has shifted. Similarly in the next iteration, we can say in the next iteration number 3, the point has came over here, centroid has moved because the mean has been changed. Similarly for iteration 5 we can see this is the new centroid and correspondingly the values are assigned. So iteration 6, the point that you can see in the form of plus has moved over here. So this is keep on moving. So this way we get the solution. So we can see the all iterations in a single shot. Iteration 1, these were the initial points. Iteration 2, after calculating the mean between these and these, this has shifted to over here. Similarly for this and this, the new mean value taken, so the centroid has shifted. Iteration 3 we can we can say the new centroid point came over here and here. For iteration 4 they are coming like this, iteration 5 and iteration 6. So this is how k-means clustering works and how the data points are assigned with the help of the central values, that is known as centroid. So that's all about the basics of k-means clustering. In the next video we will solve the k-means clustering numerical problem. So thanks for watching the video.